Okay, hi. So we've read the three functions so far, which is sine, cos, and tan. Okay, but now as we dive deeper into trigonometry, we have to understand three new functions. It's simple functions. So these three functions are cosecant, secant, and cotangent, or in their short forms, cosec, sec, and cotan. Now you may ask what these three functions mean. So cosecant of theta is actually equivalent to 1 over the sine of theta. Secant of theta is 1 over the cos of theta. And as you've probably guessed by now, cotan theta is 1 over the tan of theta. Okay, these three are the reciprocals of sine, cos, and tan. And one function for them all to be true, because they sit in the denominator. Theta cannot equal to 0. Theta can occupy any value but 0, because if theta occupies the 0, these three functions will become invalid. Okay, let's consider an example where we can use these three reciprocal functions. Okay, so this is the question. Given A is obtuse and cotangent of A equals -3, find the exact value of secant A and cosecant A. Okay, so from this question, we're given that A is obtuse, which means that the angle A is somewhere between the 90-degree mark and the 180-degree mark. So it's somewhere here. And we are given that cotangent of A is -3. Okay, so if cotangent of A is -3, then the tangent of A is the 1 over the cotangent of A, which is 1 over -3, which is -1/3. And we know in a tan function that the numerator is the opposite and the denominator is the adjacent. So therefore we know that this angle is in quadrant 2 and the tangent of it is -1/3. Using these two, we can map it on the graph. So let's just draw a random triangle where this is A, and this is A, and this is alpha, because alpha is 180 minus A. Okay, so this is the triangle we're dealing with, and for this triangle the opposite is 1 and the adjacent is -3. Okay, so we already have the triangle here. So now they're asking us to find the secant A. So secant A is 1 over cos A. So we have to find the cos of A. So here we only have the opposite and the adjacent. To find the cos, we're going to use the adjacent over the hypotenuse, right? Okay, we have the adjacent, which is minus 3, but to find the hypotenuse we have to use the Pythagoras theorem. So that will be 1 square plus minus 3 square, which is 1 plus 9, which is the square root of 10. Okay, so the secant of a is 1 over minus 3 over the square root of 10, which is equal to the minus square root 10 over 3 once you flip the equation, once you flip the fraction. So we have the secant a is equal to minus square root of 10 over 3 based on these two conditions. So part B of the question is to find cosecant of a. So we're gonna start by drawing the same graph where this is alpha and this is minus 3, 1 and the square root of 10. So the cosecant of a is 1 over the sine of a, and sine is opposite over the hypotenuse. So the opposite in this graph is 1 over the square root of 10. Okay, so 1 over square root of 10. If we flip the equation, the answer is the square root of 10, and this checks out because the value of sine is positive in the second quadrant. Now, before ending the video, I just want to reiterate that the system of quadrants and which functions are positive and negative is the same for both sine, cos, tan, and their reciprocal, which means that obviously all are positive here. Both sine and its inverse cosecant is positive here. All tan and cotan are positive here, which is its inverse. All cosine and secant are positive here. And yeah, so all the other trigonometric functions are negative besides the ones stated in quadrant 2, 3, and 4. So so this is part 4 of the trigonometry masterclass. The next one will start on trigonometric identities before we dive into solving trigonometric equations. Thank you.